Alright, so let's start off now with a static logic hazard example. Here is an equation for a function in compact minterm form. Sorry about that. 0, 1, 5, and 7. Let's stick this guy into a K-map. So we have 0, 1, 2, 3, 4, 5, 6, 7. The rest are zeros. And we would normally circle this like so, where we use the fewest number of bubbles possible to cover all of the ones to get a reduced SOP form. So this is going to be f is equal to, this is our A naught B, or A C. Alright, so this is our typical reduced SOP form. Now, as you can see though, we have adjacent ones here that were not covered in the same grouping. So I'm going to go ahead and just put a red circle around that grouping. This is where we can identify a static logic hazard. Why is this a static logic hazard? Because there is a single bit change between these groupings and they were not included in the same term. So there is a potential for a glitch. Now let me show you the reason why. To do that, we're going to draw a circuit diagram. I'm sorry, I need to include here that this was A naught B naught. Sorry about that. I'm going to draw a circuit diagram and a timing diagram and show you the glitch that can occur from this grouping. So in our circuit diagram we have A naught B naught. And we have A and C. These are going into an OR gate. And out comes F. I'm just going to label these outputs here X and Y so I can draw them into the timing diagram. Alright. Now we're going to look at this case where we're transitioning. This is the 1 input, so it's the 0, 0, 1. And this is the 5 input, the 1, 0, 1. So we are transitioning here from the 0 to the 1 on the A, and the B and the C stay the same. So those are the input conditions that I'm going to give in this timing diagram. So we're going to have A is going to transition from high to low. And B and C are going to remain the same. B is going to be 0, C is going to be 1. Alright, so let's first look at what A naught and B naught are going to be doing. Drawing that in our timing diagram. Now remember, we're going to use a real world, assuming that the inverters have the same, well, we're going to assume that every gate has the same propagation delay. So here we go, A naught. Here is where the change occurs. But because of the propagation delay, it's going to wait a little bit. So there's A naught. B naught has just been low, or B has just been low for a long time, so it's just going to be high for a long time here. Okay, so we have A naught and B naught. Now we have X. X is going to be A naught ANDed with B naught. So as you can see here, we're going to look at A naught and B naught. And X is going to be low because you need 2 1s to get the AND. Here we get a change, but because of the propagation delay, we're going to wait a little bit and then change it to high. Because here you see we have a 1 and a 1 which will make it high, but it takes a bit of a delay to get there. Okay, let's look at Y. Y is A and C. C is always high. A is high and then low. So Y is going to be high until this point, where it's going to drop to be low here. Alright, so that makes F is going to be X or Y. So here we have X or Y is going to be high, but now at this point they're both low, so it's going to drop from this point with a delay to low, and then it goes high again. So this right here is what we call the glitch. And as you can see from this timing diagram, the glitch was caused by these propagation delays in real-world circuits. So this glitch occurs because F was supposed to stay the same. We were expecting when we give either of these inputs, the 001 or the 101 input on A and B, we should get, according to this truth table, a 1 output. But F didn't stay 1. For a moment in time, it dropped to 0, which can cause a glitch in the output, as you see right here. So to get rid of this hazard, what you do is you add a cover term. So this static logic hazard can be fixed with the cover term, which is this one right here, B0C. So your glitch-free circuit is going to be F equals A0 B0 or AC or B0C. By adding B0C, if you added that to the timing diagram, you would see that no glitch would occur in the output.